a population proportion. Our first topic of the course. We're going to have many. I say many. About 10. Maybe even fewer. But first, we're going to be estimating a population proportion, which we call little p. By definition, we call it little p. Symbols are nice. Symbols are nice in this class. It becomes very tedious if you constantly write words, so it's nice to have symbols. But see, that's a population proportion. That's like mu, or little sigma. You never actually know him or her. You don't know it. It's out there floating around, but you don't know what it is. So just like you don't know mu, who can you know that's related to mu? Remember this from 243 we talked about earlier today? You can know x bar. So just like you can't know little p, you can utilize the sample proportion. What do we call him? P hat. Remember one term, had a bunch of nursing students in here. It was great, one of those little outlier years. I had like half a dozen nursing students. And I said, using P hat. And I heard this, like, that's interesting. What's so funny about it? Every time I said P hat, little jokes and laughs. And I was like, what the hell's going on with the P hat? And then one day, they brought in a P hat. Apparently, in hospitals, they have this thing called a P hat. And what it is it's a little pilgrim-shaped hat plastic thing that when you turn it upside down, it's got like markings like 1 ounce, 2 ounces, 3 ounces. You put it on the toilet, you pee into the hat when you take a sample. And I had to wear the P hat whenever I said the word P hat. Never asked if it was used or not. Go ahead, Sean.
The symbol for P hat is still a little p, right?
It's little p with the hat.
Right.
Yes, sir. And it's not usually called P hat. If you spell it out, it's fat, yo. So, P hat. It's also very hard to get typed on Microsoft Word. If anybody ever needs it for that, I can copy and paste you a P hat, and you just copy and paste it. That's why I figured it out once, and then I just copy and paste it whenever I need it now. Because honestly, it's too much pain in the ass to figure out. Go ahead.
That's a big P hat.
That's little. Good question. These are all little p's. Yes, and this is a problem with Sean because I write in all capitals. These are lower cases. Yes, thank you for that, Kathy. It's a very good question. These are most definitely all lowercase. Oh, this is not writing. Yeah, and the reason I say that, I don't recharge these things. The reason I say that is because I save capital P for something extraordinarily important in about 3 weeks. And it should be saved for that because that's what the journals print it as. When you read journal reports, have you guys heard of p-values in your research? Those are capital P's, and they show up as capital P's in the journals most of the time. Sometimes they mix and match. One of the most frustrating things about introductory stat textbooks is they make everything lowercase. And then little p here means this, and little p somewhere else means a p-value, and those are not the same thing, not even close to the same thing. So I keep these lowercase, and I keep the p-value capital P. And there's a p-bar later, we'll deal with him when we get to him.
Lots of P's.
All lowercase except for the p-value. Good, very good question, thank you for that. The calculation of p hat is really simple. So a p hat is a sample proportion, right? Now we know what we think little p is, yeah? We think little p, according to this, is 1/2. Now what does that 1/2 mean again?
1 out of 2 times.
A little bit more.
On the average, out of 1 out of every 2.
I love that. On average, over a long period of time, i.e. infinite trials, 1 out of 2 are going to be heads, yeah? On average, over time. So this is over infinite trials. Over infinite trials, the number of times that we get heads is going to be half of those infinite trials. And you can see, if you've had calculus classes before, as some of you had, the problem with that mathematics. You can't divide infinity into a number and get a half. It doesn't work that way. You don't divide infinities. You talk about them. You need to talk about them. But that's what this half means, on average over time. What does time mean? Time means infinite time. Okay, well, that's ridiculous. We can't do that. So we get p hat instead. I didn't mean to say it like that. P hat instead. P hat, lowercase p hat. Now, it's set up the same way. It's set up exactly the same way. It's a fraction. It's number of heads in your experiment. Let's spell that. Experiment. Let's spell it correctly with an I. Divided by number of times we spun in our experiment. So let's think about this. I'm going to go to my TI real quick and get this number. If I run one of our stats real quick, it'll give me all these numbers. 27, so I'm going to call that 270 since you guys spun 270 times, right? I'm going to move this away from X bar and move it towards proportions. On average, you guys got 4.15 heads out of 10, which is just below 5, yes? So our gut, at least metric a little bit, is kind of close to, it's a little bit low. Just about one low of what it should be. I'm going to move away from that and go strictly with number of trials that we spun and number of heads we got in total. So, in total, we spun 270 times. 27, as Aaron just said correctly, times 10 is 270 trials. Now, this is where the TI helps me a little bit. We also, anybody know how many heads we got based on what the TI is showing you? Yeah, the TI gives you the number of heads, but it doesn't say number of heads equals this. 112. That's exactly right. See that 112 up there? Summation of x? That's 112 is how many heads we got. Now, you would just be given this in my class. I would say you did this experiment this many out of this many. I would tell you that. TI's being cryptic. We got 112 heads out of 270 trials. What does that work out to be percentage-wise? 135 out of 270 would be exactly a half. So go ahead. I'm sorry, Mike. I talked over somebody.
It's 41.
41.48, which is similar. Good. So this is point. I'm running out of space here. Let's do for this. About 0.4148. I'm gonna call that 41.5% just to make life easy. We can deal with precision later. Now we're just about out of time today, unfortunately. But let's set the stage for Monday. Tuesday, I mean. Don't come here Monday. You can come here Monday if you want. You'll be sitting through Doug Nelson's Math 112 class.
You have office hours on Monday.
I do. I'll see you then. Maybe. I was saying something. Oh, let's set the stage for Tuesday. Say that again, Stephen. Say that again.
With Doug's class, you're going to deal with infinite.
You are, at least at some point. No pun intended. We think half the time we're going to get heads. This is our gut, right? The data says 41.5% of the time we get heads. That's my question. Is that close enough to that to make us go, they're different? Or is it close enough to that to make us say, there's no reason to think they're different? What do you guys think right now? If you have a thought right now, including, I don't know right now. So who says they're close enough for government work? 41.5% is close enough to 50. Good.
For government work.
For government work. Not 0 government work percentage, okay. So close enough. Who says they're different enough to be concerned? Sean says both. Good. Who says we're not real sure just yet? Good. Sean has voted all 3 times. Excellent, my friend. That's perfect.
It's a 10% difference.
It's almost a 10% difference. 8.5% difference.
Plus or minus.
That is the key, isn't it?
What is that?
The key is what's the plus or minus around that, because we haven't addressed that yet. What's the plus or minus? This has to have a plus or minus, right? If we develop the plus or minus on that, Chris, what'd you say? Go ahead.
2.
Right. Oh, the plus or minus is 2%? It could very well be. We have to calculate it. That's what we'll learn on Tuesday, yes? How to calculate the plus or minus around that variable.
So make that 60%.
Maybe. Depends on how big plus or minus is, right? If it's 10%, that could go up to 51.5. If it's 20%, that goes up to 61.5%. No, it is, Aaron. But it has to be adjusted because now we're being inferential. We're not just saying the standard deviation of this distribution anymore. I want to take this distribution and apply it to all these. See? The 2 point whatever it is here. Yeah, that's only for this particular sample. We need to adjust it using the central limit theorem so it works for all possible samples that we will draw. That's the part 2.4. That's right here. Other than the fact that Rebecca made you come here. But she made you come here because of that idea. Is that fair?
Yeah,
And it's total. That's okay. It shouldn't make sense on the first week. It'll make sense on Tuesday when we start putting it together. I promise you that.
Is this where stats gets done?
It's always fun. I don't know, it's always fun for me. That's a loaded question,
I
sister.
watch the news and all through the news I'm saying on average over time.
Well, you should be saying that, now shouldn't you? You should be saying that every time on average. Yes, pretty much.
What's the symbol for Phi Sigma?
Phi Sigma? Usually, you mean 6 Sigma or 5 Sigma? Or any Sigma?
Give me 5.
5, just 5 back.
So they're just putting a number in front of the sigma.
Yeah, multiply out, 5 standard deviation, multiply out times 5. 6 Sigma was a big one back in the day.
Yeah, but 5 is what we're using for like the CERN detector and everything now.
Oh, really?
Yeah,
Not
they're using
6.
5. No, so when they said it just, the Higgs was discovered?
Yeah.
It's based off of 5.
5 Sigma,
Yeah.
that's interesting. So they're allowing for a
Me too.
lot of uncertainty.
Oh, yeah.
That's pretty
I thought it was gonna be 6.
Of course, it's
but
like
when
what
you
you're
look at
thinking
the
about.
standard on the international level, they say, hey, it's at 5 now.
It went from 3 to 6 back to 5. They're deciding. Remember how we talked in 243 about box plot, IQRs, and why is it 1.5? And I kept saying, it depends on when you talk to who.
Sure.
We're seeing that here apparently too. 3, 6, 5. It's like roulette wheel at some point. No.
Well, hey, if I spend as much money as I did on the CERN, I
Yeah.
can lower it to 5 too.
Yeah, maybe, right? Because it becomes exponentially more expensive to control for that extra one. Oh, I'm with you, Sean.
See you after the weekend, Sean.
Yes, you will,
I
sir.
want some.
Good. Can you start with that question? No, I'm going to answer right now. But if you can remember to bring it up again. So here's the thing. 4.1 is the average percent we saw hit when you guys did this experiment.
I don't like it.
We get 4.1. Probably not, right? Probably close to 5%. The population's average, because it's based on a specific number of trials. It's a number, but we don't know what it is out there. It's somewhere out there. So it's a bullseye. Think of it as a bullseye, right? There's a target we're shooting. So the coin is a person. So it's a measure of that person. Maybe it's how far a normal person can see. Not years later, not how far a normal person can see before it's blurry. Maybe it's the range of smells a normal means, but a normal person
We
can
have
see.
like a program.
Maybe it's the temperature difference of a normal person that bounces on their fingers. Things like that. Maybe it's if you're on a lake checking for purity, you take a second disc.
Really?
A little round circle. Distance, you drop that bad boy down, and when you can't see anymore, that's a little more clarity. On average, how clear is Walter Lake, Crater Lake?
Not too bad. Tuesdays are the worst. I mean, from the gate.
Crater Lake is just no, 114 feet is the clarity on it. That was the it's like 1900 feet.
Yeah, it's almost.
Yeah, it's almost 2000.
Okay, at least we get brains.
Okay, look, Allie, does this make sense? This is what you're trying to find. Please do. Here's what you're trying to find, but you can't see it. Your data is doing this around it. Your job is to be able to measure these off distances. You're never going to get two. Exactly. We're never going to get two the true value. You're going to get close enough to be like, oh, it's between this and this, and I can live with that. That's what it is. Cool? But bring it up. Please bring it up on Tuesday. You mean Blackboard? I haven't even looked at Blackboard yet. That's tomorrow for me. So here's, I will tell you the same thing. I think that's some way to do it. I emailed you, Ali. I think I told Ali, if you get a 0 on your progress report tomorrow, then something happened and we'll deal with it next week. So we will deal with it over the next couple of days, the assessment, submission stuff. We'll make it all work. So if you get a 0 on it, then realize something's wrong, and then we'll fix it next week and we'll make it right. I know, and I'm considering not dumping it. You probably are doing it right, and I will get into that tonight, tomorrow morning. I'll start getting there and start doing this stuff. You take care of it, don't you worry about it.
But I'm not sure if I need to I got the hard copy.
That's perfect, so if you get the progress report and it says 0, then we'll do the hard copy.
What would you do if you had the Joker set?
What would I do?
How would you figure the probability.
Just add them into 50, it would be 54. You still have 26 red, 26 black, but now you have 2 nons. It's like roulette at that point.
Right.
You've got the 2 green spots that drive it down from 50-50, so it's not 50-50 anymore, it becomes a little bit less than 50, which makes it, hold that thought, because then I gotta shut this stuff down and get ready to get going. But that's, you would just account for it in the same